Hello, Course 3. This is Lesson 97 on recursive rules for sequences. I'm going to go over some of the practice problems here because this lesson can feel very confusing. So let's first define some of the notation. So when you work with sequences, you're going to see the lowercase letter a used a lot to show the value of a term in the sequence. And usually you see it like this. A and then n represents this subscripted or n, lower n there, is the term number. So where that term falls. And the a represents the value of that term. So for this, if I was to have, let me just get a random sequence here. Let's just say I have 2, 4, 6, 8. Well, this is the first term, this is the second term, this is the third term, this is the fourth term. So using our sequence notation here, I would say, if I was going to say, what is the value of the third term? Well, the value of the third term is here, it's 6. So that's why we use that notation. And then we'll often use, you'll see this used a lot for this lesson. This is just saying what's the value of the first term? Well, in our example sequence here, that would be 2. And then you'll also see this notation. So what is the value of the term right before? That's what that's saying. What's the value of the term right before? So if I'm looking for the value of, let's say, the fourth term minus 1, I'm really looking for the value of the third term, which is, in this case, 6. All right, hopefully that helps explain that notation a little bit more. You just have to get used to working with it. We're told to write a recursive formula then for the following sequence. So we first want to define the first term. So a subscript 1 equals 1, right? Because 1 is the first term in this sequence. And now let's write the rule. Well, the rule is we're going to multiply 4 times the previous value to get the next value. So I'm going to say the value of any term in this sequence is equal to 4 times the value of the number before. All right, so let's test this out. So let's say with our sequence here, I want to find the value of the third term in this sequence. So I'm going to take 4 and I'm going to multiply that times 3. So that n is that 3 still minus 1, which means I'm going to take 4 and I'm going to multiply it times the value. Well, 3 minus 1 is the second term of the sequence. Well, the second term of this sequence is, let me see, 4. So 4 times 4 is 16. So the third term in the sequence has a value of 16. Okay, not so bad once you break it down a little bit. So just slow down, take each step here. I just showed you the first one, how to do that. Now let's look at the second one. I'm gonna encourage you to pause the video at times so you can think about what the next step might be. So the terms of the following sequence are generated with this formula. This is not a recursive formula yet. We have this n, so we know this formula generates any term in the sequence. We want to generate a recursive formula. So we'll look here. First of all, we'll identify the first term. And pause really quick to see if you can identify that easily. 3 seconds. Hopefully you got that it's 3. That's easy, right? It's the first term. All right, now I need to define what's going on here. So basically I take this first term and I add 5 to it, the value of the first term, to get the second term. I add 5 to get the next term, 5 to get the next term. So I can find any term in this sequence by taking the term right before, the value of the term right before, and adding 5 to it. And there is my recursive formula. Let's check it out. So if I want to find the value of, let's say I want to find the value of the fourth. Now we already know it's 18 here, so my formula better reflect that, right? So I'm going to take a, well, n minus 1 would be the third value, the third term of the sequence. I'm going to add 5 to it. Well, the value of the third term is 13. I'm going to add 5, and 13 plus 5 is 18. So the value of the fourth term of the sequence is 18. And that's how you create that recursive formula. So on C, let's start. One of the terms in the following sequence is 729. Write a recursive formula for the sequence and then find the term that follows 729. So you don't have to go through, and it's funny, I see this on tests sometimes, students who never actually learn the lesson, and they'll go through and try to write the sequence all the way, and sometimes it works, and then eventually these sequences get too long to do that. So let's go ahead and do it the right way and create this recursive formula first. So we know the first term is equal to 1. And then pause for a second here, or I'll give you a couple seconds here just to think, what's the rule going on here? How do we get to the next term? And hopefully you saw them just multiplying by 3, right? Each of these is a multiple of 3. So I can take any term in this sequence and I can multiply it by the 3 times the value of the previous term. And I'm going to now, I'll set it up for you, but I definitely want you to try to solve this. So A, they want us to figure out which term follows 729. So we don't know what 729 is. Even the n is unknown right now, but we're not worried about that because we have the value here. So 3 times, well, this number before is the 729. So go ahead and solve for that. And again, we're not worried about what n is. We just want to find out what the value of the next term is. We can use this recursive sequence for that. This is not the answer yet. I want you to go ahead and find the final answer there. And then for D, I also want you to do this one. Which formula below generates the term of the following sequence? So you need to find the rule and see which one of these sequences here is matching that rule. All right. Good luck with that. So 2 answers left for you to do, but hopefully you're finding this lesson a little clearer to understand.